School of Geosciences presentation for Open Day. What I'll try to do today is give you an idea what geoscience is, what geoscientists do, and what the career opportunities look like in this field. Now, why choose to study geosciences? You might want to explore the world, but also make a living. But above all, you want to make a difference. Geoscientists work in the field, the laboratory, and with computers to seek a greater understanding of the Earth. They try to help solve the world's most pressing problems. Geoscientists help protect the planet by studying it, learning from it, and predicting what the future might bring. They also perform environmental assessments, study global environmental systems. They locate water, mineral, and energy resources. They try to predict natural disasters, and they help us be better prepared for them. So as a geoscientist, you can make a huge impact on the world around you. Now, some of you might have heard of the expression, the Anthropocene. It's the most recent geological time period, the one which has been particularly influenced by humans. You'll see here that it's made the news in The Economist, many other places recently. And the graphs on the right-hand side encapsulate what the Anthropocene is all about. It's essentially is very much characterized by a huge increase in population, in GDP, in investment, an increase in damming rivers, water use, fertilizer use, and urban population. You can also look at paper use or the rise of McDonald's, the rise of motor vehicles, telephones, or tourism. They are all an expression of the same thing, the enormous impact that we have on the Earth and its living systems. Now, geologists, geographers, and geophysicists, they're all the subdisciplines in geoscience. They try to traverse all the different scales of Earth processes. And these are vast, as we are trying to understand the evolution of planet Earth, because the Earth started being formed 4.5 billion years ago. And so we study the very long-term evolution of the Earth, while supercontinents formed and dispersed. By the same token, we study very recent and current processes, earthquakes, volcanic eruptions, a process that happened over a human lifetime. At the same time, we study geological and other objects on tiny scales up to very large scales. So we start with the whole globe, the Earth, and we study microfossils at the other end of the spectrum, or tiny minerals in rocks. And of course, all this is being done in a digital way. So digitizing the Earth is a promising field to keep track of the vast array of complex data that we need to deal with to understand how the Earth works and how it might evolve in the future. And so, as I mentioned before, we have three subdisciplines: geography, geology, and geophysics. Together, we reflect Australia's oldest departments of geology, formed in 1893, and geography in 1920. And together, we are rated well above world standard. We are trying to apply and expand the knowledge that you already have. And so, in addition to the overriding fields that I've just mentioned, we interact with the fields of earth and environmental science, with physics, chemistry, biology, mathematics, statistics, and information processes that include technology and software development and databases. Now, the areas of study include rural and regional development, Asia-Pacific geography. They might include e-geoscience, electronic geoscience that is mainly based on using computers and geographic information systems to decipher how the Earth works and how humans interact with it. We look at environmental change and management, both onshore as well as offshore geoscience. We look at the origin of the Earth, plate tectonics and Earth materials, look at resource exploration, natural hazards, and disaster risk reduction. Now, focusing in on geography, geographers are particularly concerned with human-environment interactions. So they try to achieve an integrative view of global environmental issues. They're concerned with sustainability in urban and regional Australia, as we are facing major changes, enormous growth of our cities that we are trying to manage. We are looking at development and sustainability in the Asia-Pacific region, at climate change impacts and adaptation. Now, in marine geoscience, we are particularly concerned with coastal change. I mean, you might have all read in the newspapers about the potential effect of sea level rise together with king tides. Some coastal areas around Australia have already suffered from these changes. Now we're studying these changes, trying to come up with ways to better manage them in the future. We are carrying out pollution studies. As part of marine geology and sedimentology, we look at the evolution of climate and ocean currents as reflected in sediments on the seafloor, and we model plate tectonics back through time to understand the natural fluctuations in climate change that have happened over long periods of time, long before humans existed. We look at what drives the growth of coral reefs, and we look at the evolution of continental shelves, the submerged portions of the Australian continent that we still know relatively little about. Moving on to geology and geophysics, geologists and geophysicists investigate the movement of tectonic plates, the origin of the Earth, and the formation of all those natural resources that has made Australia a relatively rich and lucky country. And so as part of finding deep Earth resources, we study the long-term evolution of the tectonic plates, in particular the early Earth, seeing that Australia is a very old continent. We look at fossils to unravel the time scales and the surface environments through time of the evolving Australian continent. We use geophysical data to look below the surface. We use seismic data and other geophysical methods to explore the subsurface that we cannot sample directly. And of course, we use computers to analyze geological and geophysical data together. And lastly, we also are involved in investigating natural hazards and how we can manage them better. Resource exploration and extraction, as I mentioned before, is particularly important for the wealth of Australia and will remain important for its future wealth. So we're looking at economic minerals, and we're looking at how the continent has been structured through time to create particular geological niche environments that became prone to mineral emplacement. And that involves field work. That's, of course, part of the fun, studying geosciences, going into the field and actually looking at the rocks and learning what stories they have to tell. We're also looking at environmental management, that is a natural side effect, so to speak, of exploration. And we are trying to make sure that these areas where mine sites were built, that they are ultimately returned as much as possible to their natural setting. Information technology plays a big role in our entire field. We are big on geographic information systems that we use to both keep track of the multitude of the data we collect, as well as analyze them. Computer modeling, it's ubiquitous.